Okay, so throughout the last few days and the lessons that we've worked on, we've talked about both radicals and some rational exponents. So what we're going to be working with in this section 923 is the relationship between those rational exponents and expressions and radical expressions. Well, how are these nth roots related to the rational exponents? So have your calculator available. You might need it, and be ready to take some notes. Here we go. Okay, so the radical notation that we're going to be working with, and just kind of the relationship here. If a is a real number, a's being our base, is a real number, and n is a positive integer, so this only applies to when we have positive numbers. Now, n is an integer, so in other words, this could be a 1/2, this could be a 1/4, this could be a 1/23. Then we have n root of a. So the 1/nth, the denominator, determines the type of radical that we have. So we can write a base with a rational exponent as a radical with an nth root. If a is a real number and m is an n, I don't know where I'm going with this. If a is a real number, m is an integer, and n is a positive number, and the nth root is a real number, then we get a to the 1/n. So we can actually write it like this as well. So they can go back and forth between these two. So the radical sign is just our symbol, and we choose the n, which is our index. The radicand is the number under, which we've talked about before. Okay, so let's actually work with a couple of these. So the first set of directions here are to write this in radical form. That is to take it from an exponent and put it into radical form. Now, what was said before was that it's a to the 1/n. So this is different because it's 2 over something. So this is actually 8 to the 1/3 power being squared. Remember, this separates it. So you can think of this the numerator as the exponent, and the denominator as the nth root, as the index. So if you consider it that way. So this is saying I want the cube root of 8 and I want to square it. This can also be written as the cube root of 8 squared. Here's why it works both ways. So you can either use parentheses and say the whole thing gets squared, or you can say the 8 is being squared. It works both ways. And if I go ahead and simplify the cube root of 8, that's 2 times 2 times 2, that this cube root of 8 part really becomes a 2. Then I have to square it. The outcome is 4. Let's take a look at this one. 8 squared is really 64. So this is the cube root of 64. Well, 64 is 4 times 4 times 4, and the cube root becomes 4. Okay, listen to that again if that's confusing. All right, the next one. This is identifying this as a 5th root that's being raised to the 4th power. So the first thing we're going to do is write this as a 5th root of negative 32. Then you can choose to put the 4 on the outside or the 4 underneath. I prefer the 4 on the outside only for my thoughts, but I like the look of the 4 on the inside because it looks cleaner to me. But when I have it on the outside, it reminds me to take care of the 5th root first. And the 5th root of negative 32 is negative 2 times negative 2, negative 2, and another negative 2. 1, 2, 3, 4, 5. That's 2, 4, 8, 16, 32. There's my 5th root. Now I'm going to take that and raise it to the 4th power. Don't forget parentheses. The outcome of this is positive 16. Okay, next one. This one does not have the negative on the inside, and that's important to recognize because when I put this underneath a radical, I cannot put a negative 16 inside of a 4th root anyways, because all of my 4th root radicands must be positive because it's an even power. So now I'm going to put the negative on the outside of it, and I'm going to cube this. So it's going to look like this. So the fourth root of 16, 2 times 2 times 2 times 2, is 2. This gets cubed, and there's a negative. So the outcome is -8. All right, next one. These have variables, so it's a little bit different. In fact, because of the variables, I don't have to worry about any simplifying unless they exceed the denominator. So 5/6 is going to be the 6th root of x raised to the 5th power. And here's where I like the exponent on the inside, although both are absolutely correct. Now, nothing actually can be simplified from this because I don't have a perfect 6th. Next example. It's really important here to recognize that the 3 is not under this power. It doesn't have the exponent on it. So the 3 is actually like a coefficient out front. Then I have the cube root of x, and you can put the squared right there. All right, the next one, because of the negative exponent, I have to handle it first, because the only time we can work with this a to the n is if the exponent is positive. So the 2 does not have an exponent, so it stays in the numerator, but the denominator becomes p to the positive 1/2 power. Well, 1/2 power means that it's a square root. So I can write this as 2 over the square root of p. Now, because of the exponent of 1, I don't have to make any adjustments. The last thing I would have to do with this is rationalize it by multiplying by the square root of p over the square root of p, leaving 2 radical p over p. Okay, again, look back at any of these if you have questions, just to listen to it again and see if you can follow through your notes. Let's keep going. All right, these are different because they're a quantity. And I can't break inside of that quantity because first of all, there's nothing I can combine. In the order of operations say combine stuff inside. I can't. The next thing it says is handle the exponents. Well, in this case, we're just going to turn this into a radical. It's a 4th root because the denominator talks about the type of radical. And on the inside, it's just going to be 3a plus b. The parentheses are not necessary because it's an exponent of 1, but it's nice to keep them. The next one is a 5th root of this quantity, 4x minus y, but this time it's being cubed. Because I would need 5 of them to eliminate the radical or remove anything, I get to leave it right here. All right, the last exercise of this is going to be taking the radicals and turning them into rational exponents. So we're going to go the other direction. Remember that the index is the denominator. So we're working backwards. So that means x to the 5/4 power, because the 4 is my denominator. Here, if there's no index noted, it's just a square root, so that means that I would have 3y in parentheses to the 1/2 power. Do you need the parentheses? You absolutely do. The only thing you could do otherwise would be to write this as 3 to the 1/2 and y to the 1/2. So both of these are correct, but there's no other option. It has to be one of those two. Okay, the next one. Remember how I said that this 2 could either be on the inside or the outside? Well, it's fine. That makes this z to the squared goes in the top, 5 goes in the denominator, and then I put a 10 out front. I don't need parentheses around anything because the 10 does not have the radical right now or the exponent, so it looks good. Okay, for this one, I'm going to actually handle the exponents inside first. So I'm going to rewrite this as 5 cube root 2 to the 7th and x to the, what am I going to do with those two? I'm going to multiply them, so 28th power. Now I'm going to write it as with the rational exponents. So my 5 stays a 5, and this becomes a base of 2 to the power of 7/3 because the index is the denominator, and x to the 28/3. Okay, writing this one as an exponent. This is a quantity, and the whole thing is being raised to this power based on the index of 2. So it's p squared plus the q in parentheses to the 1/2 power. Refer back to the previous page with those last 2 examples if this doesn't make any sense. All right, you guys, great job, and we're going to keep working with these.